Okay, circular slide rule, lesson 2, part 2. Some of the more funky computations that we have to do. This is where the stuff gets really interesting now, and we're really getting the most out of the slide rule. So hopefully you've really nailed the multiplication, division, and you've taken some time out to look around your slide rule and all the indicators that exist there. So you can see litres, fuel, distance, oil pounds, imperial gallons, US gallons, feet, and you've had some time to work that on the outer scale with the stuff on the inner scale, like meters, litres, statute miles, imperial gallons, kilometres. Once you understand what's there, you can really start using it to the best of your ability. And that's important because, like I said, that kind of you've got all the stuff that exists with the knowledge retention based stuff, which will take up sort of 35–40% of your exam mark. Now we're getting onto the stuff that's really going to carry you through. Now in New Zealand and I believe Australia, the fundamental part of the exam is to be able to create a flight plan and work out all of the relative components that are required to put that flight plan together and the calculations that are required to do so. And that's quite a heavy weighting on your exam. Fundamentally, you have to make sure that that flight plan is bang on the money, because the relating questions are going to be geared towards that flight plan. So you screw the flight plan up, you screw everything else up. The only way you're going to screw up that flight plan is by making the wrong calculations. So part 2, calculations, computations, we're going to run through just a couple of the really important ones, the ones that you really have to be able to nail out. And in doing so, you get this nailed and in the bag. You're pretty much on the way to a pass, and relatively quickly too. So let's kick off. Indicated or calibrated airspeed and true airspeed are equal at sea level under ISA conditions. An aircraft climbs to a higher altitude, pressure and temperature will normally decrease. It gets colder when it's higher, and the air particles become less dense. So this change requires a correction to your indicated airspeed and how that relates to your true airspeed. Because true airspeed increases with altitude. Pressure altitude will be indicated in an altimeter when the subscale is set to the 1013 hectopascals. You won't get too much on the way of density altitude calculations on your test. It'll be more around indicated to true and true to indicated. But they are one in the same. You've got to be able to, once you be able to work out pressure, altitude, and temperature compared to indicated and true airspeed, the pressure altitude calculation just comes in with that, and we'll run through it anyway. But once you know one, you know how to do both. So because the process of finding true airspeed and density altitude is the same, I've combined these two tasks into one example. The process will use the density altitude window and the temperature pressure altitude window, which is depending on the kind of E6B that you've got. I've got two, and I've noticed that my standard E6B compared to my ASA E6B, my standard has a density altitude window slap bang in the middle, as you saw in the previous picture and you'll see in the next one. Whereas my ASA one has it above the temperature and pressure altitude window. So depending on where it is, just be able to tell the difference between your density altitude window and your pressure altitude window and your temperature window. You'd be able to do that, you're pretty much on the way. So to find true airspeed and density altitude, use the temperature and pressure altitude window. And align your outside air temperature on the top with your pressure altitude at the bottom. And reading density altitude off the pointer on the density altitude window, you'll find your CAS on the inner scale and your TAS is directly on the outer scale. We will cover it off. Alright, so we'll do a quick example here. What is the density, altitude and TAS under the following conditions? So with a pressure altitude of 15,000 feet, so in the pressure altitude window, where we've got the 1,000 feet, which is the bit that moves underneath the spin wheel, you want to set your pointer, and let's start with a 0 pointer on the top part, the air temperature guide. We'll set 0 over the 15,000 feet mark, and then once we've got that, we'll then move it a little bit further around in an anti-clockwise direction to get the -30. We're not too worried about the calibrated airspeed at the moment. At the moment, we just want to be able to get that set up particularly correctly. When I said before, the E6B, the manual Wizz Wheel, is not the most accurate, and so to do very, very finite calculations is known that you can't do that on this. So the tolerances are there. So you want to be able to give yourself as close a proximity to be able to getting the 15,000 feet with the -30, the best you can, because that is then going to have to reference the outer and inner scale markers, because we're going to take the airspeed and we're then going to look on the outer scale and try and find, but we're going to look on the outer scale and try and find it on the inner scale, our true airspeed. So get that bit done first, and then we'll work on to the next bit. So what you should see is yourself being set up. Again, if you've got a density altitude window that's somewhere else, don't worry too much about that. The particular piece that you're paying attention to is where you see the pressure altitude is set to 15,000 feet, and that corresponds with a -30 degrees on the air temperature window. Now, as long as those two mark up, brilliant. And the reason I say that pressure altitude and density altitude computations are the same is because you're using exactly the same reference points. All right, you just got a density altitude window and you've got a pressure altitude window. So we'll focus on the pressure altitude stuff at the moment, and we'll just check the density altitude stuff as well so that we know how to do it. So once you've got those two lined up, and you've got your pressure altitude and your outside air temperature lined up perfectly together, we should be able to have a look at our CAS on the inner scale, and we're looking for the 15 to represent 150 knots, that is calibrated airspeed. And if we look on the outer marker, we can then reference our true airspeed, which is coming out at 184 knots. Now, again, if you're not seeing 184, that's fine, as long as you're seeing within a tolerance of 2 or 3 knots, because then when you actually have a look at the exam answers, you can see that you've got one close enough to that proximity, and they're not going to be that mean that they're going to have like a TAS of 184, 183 or 185. They're not allowed to do that because you have to be giving a tolerance within this. Alright, so we've got a few more calculations that we can practice on, but just make sure that you can reference the pressure altitude window and the pressure altitude that you need to set, and the outside air temperature and how that relates within the Wizz Wheel, so that you can get those two lined up. And then you take your calibrated airspeed, look at it on the inner scale, find your TAS on the outer scale. And then once you've got that, you know how to do the true airspeed, calibrated airspeed, pressure altitude and temperature conversions. You got it nailed. So, in true to form, we would normally do this part in a separate video where you can run the Q&As. I'm trying to incorporate it here so you still got a little bit of reference for at least some of the questions, and I've removed the picture after a couple so that you can start working from memory on how we calculate these. So let's kick it off. We have an altitude of 5,000 feet and a outside air temperature of +5 degrees Celsius. So we know that we need to take in our altitude window 5,000 feet and measure it up against our outside air temperature to the left of the 0 +5 degrees. And then we also know that we've got a CAS of 97 knots. So when we pull that round and we find the CAS on the inner scale, on the outer scale, we should see between 103 and 105. So we'll call it 104. And as long as that's what you've got, brilliant. If you haven't got that and it's something ludicrously different, like 390, stop, go back, look at the picture below. All right, and you can see where your pressure altitude is set. Instead of 1500 degrees, 1500 feet, you should have it to the 5. And instead of the 30, which is to the right because it's negative of the 0, we want it on the left-hand side, the plus of the 0. And we only want a very small increment, the plus 5. So that's the smaller marker. You get those right, you're going to get the right answer. So, 104 knots. If you haven't got that, again, look at the picture, see where it's different. Don't forget that you've got the plus and the minus around the air temperature, and make sure that you're reading the inner markers. I mean, 5,000's pretty standard. It's a notch. Okay, let's move on to the next one. So we've got 8,500 feet of pressure altitude, and again we've got this time a negative 5 degrees. So we take 8,500 on the bottom scale, and we do 1 notch to the right of the 0 because it's a negative, and we marry that up. Once we've done that, we then find 154 knots on the inner scale, and we then try and measure that out to our outer scale, and I'm seeing if you're getting between sort of 173 and 175, you're pretty much on the money. So I'm going to put down 174 for that. Great. Now we want to take the picture away and see if we can start doing this from memory. Okay, so we look at the next one and we look at 3,500 feet with a plus outside air temperature and a positive 12 degrees. Now, got that. Now we're looking at our CAS. So our calibrated airspeed is 154 knots. Sorry, read that wrong. 187 knots. 3,500 feet plus 12 degrees. And I'm getting a little under 200 knots. And I hope you are too. There we go. So, let's try this one without the visual aid. So we've got an altitude of 7,500 feet and an outside air temperature of -9 degrees Celsius. Now we can't really see a -9, but we know that that's closer to the -10 than the -8. So let's just put it slightly under the -10 number, or the indicating line, and then we take our calibrated airspeed, which we're going to read off on our inside scale. I'm getting 119. So if you're getting between sort of 117, 118 and 120, then you're pretty much on the money. Okay, we'll do one more, and then we'll try and take our true airspeed and then calculate our calibrated airspeed just to prove that we can do it. Okay, so 10,000 feet at -16 degrees. So 10,000, and just a little way past the -15 will give us a guesstimated 116. And then we look for a calibrated airspeed at 120 knots. And that gives me 135, 136. So as long as you're getting sort of 134, 136, 137, you're pretty much on the money. So this time we're gonna do the same calculation, but instead of looking on the inner scale with the number that we know, our calibrated airspeed, we're going to take the number that we do know, which is our true airspeed. So we're going to read it from the outside, and this time we're going to get our CAS from the inner scale. So we take 6,000 feet and we're at positive 8 degrees outside air temperature. And then looking on the outside scale this time, we're looking for 114 knots on the outside scale, which represents our true airspeed, which means we're getting 105, 104 knots. Now we take our 2,000 feet pressure altitude, and we've got a positive of 8 degrees. 2,000 feet pressure altitude with just shy of plus 10 degrees outside. We line those two markers up. And then we look on the outer scale for our true airspeed, which is 102, which gives me just a smidge under 100 knots. So if you've got anywhere between 98, 99 and 100, 101, you're pretty much on the money. I'm going to quickly whip out my calculator and just confirm what it thinks it is. And it thinks it's 99.5 knots, so we're pretty much on the money. And again, we've got those tolerances. We're not going to get 0.5 knots in the exam. We're going to get the closest to. So as long as we're pretty much in line with the computational mechanism of working this out, so we're pretty much in. So I'm going to let you do the next one now. 5,500 feet with a minus 6 degrees centigrade. And we've got a true airspeed of 118 knots. Now if you've got 110 knots, you've got it nailed. You work out the next two. You should have 110, 111 knots. And the last one. (160 knots). True airspeed should give us 130, 132. So if you've got all of those, you are going to ace this exam. If you haven't, get a little bit more of some more practice and get some fine tuning going on, because you nail that, things are going to be a lot easier. But remember, you've got those tolerances to be able to lean back on, which is good. So you get close enough, you can work out from the answers which one's going to be there, because they're not going to be that mean. But if you're sort of 8 to 10 knots out on these, you could run into a few problems. So if you need to, go back, rerun this, and go through the motions. Okay, let's get on to something else. Computing speed, distance, and time. One of the most common things that we're going to do with our circular slide rule. So to calculate distance covered in a specific time, all we do is we line up the speed on the outer scale above our base 60 marker on the inner scale, and we can then read off the distance covered on the outer scale. Now that you think of this as fractions, okay? Speed over base 60, as long as we get that right and we're trying to work speed from there, then we've got our distance over time. And conversely, if we're given any two of these three things, we can always work it out from there. And that's what we're going to do, is we're going to work backwards and forwards. Given speed and distance, what's the time? Given time and distance, what's the speed? Given speed and time, what's the distance? And again, we'll do this until it becomes muscle memory. So First question for you. Travelling at 100 kilometers an hour, how far will you travel in 24 minutes? Now, as we spoke about before in the previous video, the one thing that we don't get is orders of magnitude from the slide wheel. All right, so we got to have a rough idea. Now we know that at 100 kilometers an hour, how far will we travel in half an hour? We know that. So we've got our order of magnitude now, and we know roughly what we're going to be looking for. We know that it's going to be slightly under. So follow the equations on the screen. Line up your base 60 pointer, the arrow, and we know that that's 100. So we line those two up. And then we know the time, so we need to read the time on the inner scale, because distance and speed are always on the outer scales, time is always on the inner scale. So we line up time, and we take our 24, and we look up, and there's our distance. 40 kilometers. Excellent. Let's do another one. If you've travelled 150 nautical miles in 20 minutes, how fast are you travelling? Okay, so it's using the same equation, but we're asking a different kind of question. So we know the distance, and we know the time. So if we line distance, because it's on the outside, because time is always on the inside, we take our 20, we align it with 150, and then we just find our base 60 pointer, our little triangle, and that's pointing to our speed. 450 knots. Now how easy is that? And there's going to be a ton of things that you need to be able to do with these calculations. So get this nailed and you're well on your way. So I've left the, I want those two equations, speed over 60, distance over time. I need that burnt into your retina, because once you've got that as a visual, whenever you get a speed, distance or time calculation, you know exactly what you need to do. So the first question, we've got a speed and we've got a distance. So you can see that if we take our base 60 pointer and we point it at the speed, and then we find our distance, because it's always on distance and speed is always on the outer scale, then we know that once we find our distance of 26 nautical miles, we can look on the inner scale that compares to the distance, and we're given a time. Now I've got roughly between 16 and 17, so I'm going to say 16 and a half. What did you get? Something close? Again, within a 2 to 4 tolerance? Yeah, fine. Anything more than sort of like a tolerance of 3 or 4, you need to sharpen up on those pointers. Okay, let's try it again. So we're given a speed. So let's get our 60 aligned with our speed of 114. And we've got a distance. On the outer scale, we put the distance and we read off our time, because time is always on the inner scale, speed and distance is always on the outer. So I'm getting between 46 and 48, so call it 47. Cool, let's do the next one. So this time we've got a distance and a time. Now time we know is always on the inner scale, so it's always the bottom part of that fraction. So let's take our time of 32 and line that up with our distance of 78. And I'm getting 14.5, 14.6. Now we know we're not going to be travelling at 14.6 knots, because that's pretty unachievable. We're going to drop out the sky like a brick. So we must be looking at 146 knots. Check your answer before you go. 146. Okay, so we've got another one. So distance on the outside, time on the inside. We'll take time, move that round to our distance of 19. I'm just getting a smidge under 88. So if you got between 87 and 88, you're all good. Now this time we've got speed and time, but we know what we need to do. We need to move our base 60 pointer, because 60 minutes in an hour. Move the 60 across to the speed, 87, and we read off on the inner scale, because the inner scale is always time, 32, 46, 47, say 46 and a half. Sorry, 45 and a half. No, I'm getting 46 and a half. You're getting between 45 and a half and 46 and a half. You're on the money. Again, more than 3 out, not good. Okay, let's do the last one. So we've got a speed of 154 knots. So we move our base 60 pointer to 154. And we look at our time. And above our time, because time is always on the inside, distance will be on the outside. I'm getting 32.2. So again, it's not 32.2 nautical miles, not at that speed, and not in that amount of time. So it must be 322 nautical miles. Done. If you've nailed these 2 most important computations, then you're well on your way to acing this exam. So again, I've tried to incorporate the Q&As into these lessons. And if you think it's about at the end, or you think actually we could do with just another lesson 2, part 2 Q&A session where we've got a load more practice questions, let me know and we can do it. Don't forget to like, don't forget to subscribe, don't forget to share. Share the love, get other people across this. Alright, take care.